Welcome! In today's tutorial, we'll show how to scrape APIs and pull valuable data into an operational database or data warehouse. Our adventure will center around data from Hacker News, a popular tech news website. This platform isn't just a fancy web app, it also boasts a public API, a treasure trove that we can tap into. By visiting the API's endpoint for top stories, we find identifiers for each story, keys that we can use to unlock a world of detailed information. Want an example of what we can find? Let's peek into the top story at the moment, where we can see things like the title and the post ID, intriguing little tidbits that we'll be compiling into our very own digital library in our data warehouse. As a bonus, we'll even showcase how to schedule the pipeline runs so that you can continually scrape the API data. But before we jump in, let's quickly outline the plan and consider the costs. We'll be using serverless technologies, which make our lives easier, but they aren't totally cost-free. Our pipelining framework of choice is Apache Spark, and specifically PySpark, all running on the Cloud Dataproc service by Google Cloud. This is our managed environment for Hadoop and Spark workloads. For the Dataproc setup, a couple small nodes should be plenty, something like an N1 standard 1 instance running for roughly 73 hours per month, complemented by a single worker node of the same small size. Why 73 hours? Well, that's about a tenth of the roughly 730 hours in each month, just enough time to run our approximately 6-minute job every hour. We're also cutting down the persistent disk to 64 gigabytes. Factoring in networking involves a trip to our Cloud NAT service for network address translation. Though we won't be processing a lot of data, we do need a single IP and VM instance. This setup gives the pipeline egress to the public internet. Finally, we add a cloud storage bucket to our setup for pipeline definitions, configurations, and staging. Once we fit these pieces together, we get our architecture, a bird's eye view of our plan. We can expect a ballpark price of $9 per month. Now buckle up, let's jump in. Our first move involves setting up the data target. This architecture is agnostic to the type of data store, but will demonstrate the use of BigQuery. Our usage will fall under the free tier, so it won't have an impact on the cost model. We'll create a dataset and christen it Hacker News. Next is our table for the top stories, where we'll store the timestamp of data loading, the ID of the post, the title of the post, and the rank on the homepage. Larger data sets should be partitioned, but since we're dealing with a small amount of data, we can probably skip that step. Having set up our target, it's time to break ground on our pipeline solution. We'll start by setting up a simple bucket called Hacker News Top Stories in cloud storage. This bucket will house our Python code for the PySpark job, which we'll craft using the Cloud Shell, a handy tool that serves up a terminal and IDE environment for managing code and cloud resources. With our terminal ready, let's open the editor, create a directory, and set the Python wheels in motion. At just 50 lines of code, our pipeline definition is minimal, but we'll walk through it nonetheless. We've given our PySpark job the name Hacker News Top Posts to BigQuery. Remember that date time field in our table? We're going to populate it with the current time when the pipeline kicks into action. So it's a scraped on date time rather than a published on date time. Our scraping function here is designed to fetch all those coveted top posts, and that's not just the IDs from our first API call. We're kicking it up a notch and harvesting the details of each post. We'll gather this data into our top posts list. Then the true PySpark adventure begins. We create a PySpark data frame from our freshly gathered data and lay down the labels for our columns. Next, a quick switcheroo with the date time, casting it as a timestamp. This is just a simple example. If your use case is more complex, feel free to throw more advanced transformations in here. For BigQuery configs, we'll note the dataset, the table, and a temporary staging bucket. This temporary bucket holds the flat file of our uploaded data before it's loaded into BigQuery. Our journey ends at only about 50 lines of code. With that established, let's upload the pipeline definition to our bucket using a gsutil command. Our pipeline.py is now comfortably snoozing in our bucket. Let's now turn our gaze to the world of Dataproc. Within Dataproc, the workflow template approach is a must since we'll be regularly running this API scraping pipeline, A template easily enables those repeated runs. Since we'll need it eventually, let's enable the Compute Engine API before defining our assets. Then, back on the Workflows page, let's breathe life into a new workflow template. Placing a time constraint of 1 hour upon our script will prevent stuck jobs. Using the managed cluster approach, Google will temporarily provision the cluster capacity for our PySpark job. Therefore, we only run a cluster when we actually have a pipeline to execute. Let's configure the nodes in subnet. Feel free to fine-tune the nodes configuration depending upon the magnitude of your API scraping work. Remember the bucket we crafted earlier? There, we'll store our job dependencies and significant documents like driver outputs and config files. The final touch is setting up our PySpark job. This configuration is particularly simple because we don't need any extra dependencies. We're simply using the basic PySpark framework and standard libraries. It seems we've hit a mini roadblock. We forgot to enable our Dataproc API. So let's head over to the suggested URL and enable the service. Wouldn't it have been nice to get that warning a bit earlier? On the bright side, building that configuration again will give us some additional practice. After that second pass, we have a nice workflow template. Coming back to our master plan here, we've established our cloud storage, configured Dataproc, and we're positioned for efficient compute utilization. Our next task? We're setting up network address translation, enabling our Dataproc PySpark jobs to chat with the Hacker News API. Off to the Cloud NAT service we go. Creating a new cloud router is required for the setup. Be mindful that we need to run our jobs in the same region as the network address translation. The rest of the settings, they're looking sharp. Let's hit Create. A one-and-done pipeline run would be pretty anticlimactic, so let's also bring the cloud scheduler into our architecture. Though the costs are negligible, it has an important role to play in running our pipeline regularly. We'll create a job that takes place during a specific minute of every hour. Currently, it's 10:07, so let's set up our next hourly run for 10:09. We need an HTTP call to the Dataproc service to get the pipeline to run. This is simply the endpoint for submitting a Dataproc workflow, and we'll use the OAuth authentication option. We got a success status quite quickly. This means we successfully nudged Dataproc to run. However, the success is only for the trigger, not the job itself. Let's stroll over to Dataproc and check out the actual pipeline run. Let's take a look at the workflow details and inspect the output from the PySpark job. We have a successful status on the Dataproc job, a promising sign indeed. Let's open our BigQuery table and sneak a quick preview of the data. It's showing up just as we hoped. Further, the data here is pretty lean, so it'll take a long time before the storage adds up. We'll keep an eye on the comment section for any questions. Thanks for watching, and please enjoy responsibly.